So this one has, using only the completed decades, 1941 to 2000, the correlation coefficient is 0.950. Is this considered significant? And you can see if your degrees of freedom, so you have 1, 2, 3, 4, 5, 6, because that's your n, you're only using 6 data points. So your degrees of freedom is going to be 4. So if you're with degrees of freedom 4, these are your critical values. And so yes, it is significant because 0.950 is greater than your critical value. And that's exactly the answer. 0.950 is greater than the critical value of 0.811. So now the correlation coefficient is 0.942. Is this significant? And again, its degrees of freedom is n minus 2, 1, 2, 3, 4, 5, 6 data points. 6 minus 2 gives you 4. The critical value for 4 is 0.811. So yes, it's significant, and 0.9542 is greater than the critical value of 0.811. Okay, for this problem, the data reflects the 1991 to 92 reunion class giving. So we're going to copy and paste the data. It's class year, average gift, total gift. We're going to go to StatCrunch. So class year, average, gift, and then total. And I'm going to delete this column. So it tells us that we want to use class year and average gift. So we're going to use the first 2 columns. Class year is going to be your X, average gift is going to be your Y. So in StatCrunch, when we graph it and do a scatter plot, year and average are using the first 2 columns, and our scatter plot looks like this. The one that's most similar to that, maybe this one, and I would double check the points. So in 22 it was 41, yes, and then you could check 1937 was 87. 1937 was 87, yes, good. And then calculate the least squares regression line. So then we do stat, regression, simple linear. X is year, Y is average, and then compute. And we have our intercept right here. And we have our slope right here with the negative sign. Negative 0.44. Okay, so copy and paste this. Round to 3 decimal places, so 1, 2, 3. The 1 is going to round up to a 2. Negative, and then the 8 is going to round up to a 9. The correlation coefficient is listed right here with the negative sign. And we're going to round to 4 decimal places, so 1, 2, 3, 4. That would round up to a 6. Is this significant? So our degrees of freedom is listed right here. Our degrees of freedom is 10. 10. So anything between negative 0.576 and 576 is considered not significant. And since ours is less than that, this is not significant. So the value of R is not significant. And now for 1929, we're going to plug 1929 in for X into our calculator. So we have 936.892 minus 0.449, open parentheses, and then put 1929, close parentheses, and you get 70.77 to 2 decimal places. And then we'll do the same thing for 1965, and we get 54.61. And then for part F, for 2005, we get 36.65. And why doesn't this value make sense? It doesn't make sense. Let's see, the value of R is not significant, therefore we cannot use the equation to make predictions. We cannot make current predictions based on old data. No. The value does not make sense because it is not within the scope of the model. There is no linear relationship, therefore we cannot use the equation to make predictions. So the value of R is not significant, therefore we cannot use the equation to make predictions.